Hi all. Achieve section 1.2 goes back and talks about the relatively easy concept of linear functions. But just to make sure we're all still on the same page in this review material, let's look at the problems here on the Achieve assignment. My first problem asked me to find the equation of a line with a slope of 2 that passed through the point 5, 3. So you'll see here what I did was I went ahead and I said, well, all right, I'm going to use the point slope formula. There are other methods, but I think this is the easiest one. Y minus y1 is equal to m times x minus x1. We know that this ordered pair is our ordered pair x1, y1. Of course, this is our m. So we just plug that into our formula. We get y minus 3 is equal to 2 times the group x minus 5. We know when we distribute the 2 on the right, we'd get 2x minus 10. Once we add 3 to both sides, we'll get our slope-intercept version of the line, y equals 2x minus 7. And you can see here that that's precisely what I entered into the Achieve system, and it liked it. For the next one here, it's a trivial problem because it's giving us one of the special cases. Remember, whenever we have special cases of horizontal or vertical lines are always x equals, horizontal lines are always y equals. We can see that the reason, because anytime you want to know the slope of any horizontal line, well, the slope is 0. It's never going to increase or decrease its y value, no matter how far the x value goes. Now this one goes through the point 0, negative 18. So if you wanted to plug that into your formula, you know the right-hand side's just going to cancel out because it's going to be 0 times the group x minus 0. On your left, you're going to have y minus a negative 18, or that's going to be y plus 18 on the left. When you put it in slope-intercept form, solving for y, that's going to give you y equals negative 18. That's just a horizontal line going through the y value of negative 18 for all x values. And you can see that that's the answer that I put on Achieve. For the next one, goes back to finding the equation of a line that's not just a horizontal or vertical line. In this case, the slightly tricky thing was instead of giving me ordered pairs, they just told me the x-intercept and y-intercept. Of course, we know when they tell us the x-intercept, they're giving us an ordered pair. Because whenever the x-intercept of 3, you know that the y value is always 0. And if you have a y-intercept of 4, well, you know the x value at that point is 0. So we have the ordered pairs 3, 0, and 0, 4. In order to find the equation of the line, I first need to find the slope. So I went in and I said y2 minus y1 over x2 minus x1. That gave me 4 over negative 3, or actually negative 4 over 3 when I reduced it down. I'd prefer the negative in the numerator myself. Now, I plug that into my point slope formula along with either of these points. It looks like I chose the first point. Doesn't matter. Either one would work. Y minus 0 is equal to our slope, negative 4/3 times x minus x1, which is x minus 3. You distribute through the negative 4/3 on the right, and you'll get your negative 4/3 x plus 4. And you can see that that's the answer I had on Achieve there. For the next one here, it's pretty quick. It's just trying to get you to see that the slope gives us a pattern from one ordered pair to the next. So what we're supposed to understand in this problem is that the y value is changing negative 3, negative 5, negative 7. So it's going down 2, down 2, down 2. As the x value is increasing 1 here, so you have to assume that since the y value is doing the exact same pattern, the x value has to do the same pattern. So the x has to continue to increase by 1. Now, you could have also went ahead and found the slope here and said, well, the slope is just the change in y over the change in x. Your slope is going to be negative 2 over 1. So you can say, well, negative 2 over 1, then that same slope has to be occurring here. You go down 2 again, you move to the right 1, boom, we got our b value of 5. And you can see that that's what I entered in to Achieve for that one. Now, for the next one here, It's giving me a chart here that's representing the period T of a pendulum is measured for the pendulums of several different lengths. So it's saying that the time it takes it to do one period is depending upon the length of the pendulum. So it's saying that when the length of the pendulum is 11 centimeters, the time of the period is 4/10 of a second. That second column, when the length of the pendulum is 21 centimeters, the time for the period is 0.6 of a second. And then I can see it goes 26.8 and 31.1. Now the following questions, it's just asking us to find the slope from one set of information to the next. So in the first one, it's asking me to calculate the slope between 11.4 and 21 and 0.6. So I've done that here. I just said, well, it's the change in y, 0.6 minus 0.4 over the change in x, 21 minus 11. That gives me a change in y of 0.2, a change in x of 10. 0.2 over 10 gives me 0.02. Now for the second slope, and I'll refrain from showing that on the page just a second, just so you can keep an eye on my work here. It was just asking me to find the slope between the second and third column. So that's the ordered pair 21.6 and 26.8. Again, the change in y over the change in x. The change in y, again, it's going up 0.2 of a unit, but the change in x goes up 5 units. So our slope in this region is 0.04 as opposed to 0.02. Now, the slope between the last two columns in there, between 26.8 and 31.1, again, I did the change in y, 1 minus 0.8 over 31 minus 26. I got a change in the y component, again, of 0.2. But the change in x of 0.5, giving me a slope of 0.04. Now, the last question here, and it took me 4 attempts to answer this. You'll see over here, all of the questions I answered correct on the first attempt. This one took me 4 attempts simply because I didn't ever scroll down to see the final question. I was like, I'm not doing anything wrong, and it's counting it wrong. It's because I didn't scroll down and answer the last question. It's going to ask you a last question in this one. Does this information yield a line? And you say, well, no, of course not, because in order to have a line, you have to have a constant slope. The slope in this information is changing. It starts off increasing at a rate of 0.02 seconds per centimeter increase, but then it goes up to 0.04 seconds per centimeter increase. So that's certainly not going to fit our information or the requirements in order to have a line. You can see that here if I scroll down, or well, you can see how I answered the information. I kept on just hitting next question. It would say, you're doing it wrong. You're doing it wrong. So please make sure you don't make that same mistake. Make sure you scroll down and answer this question. Now on yours, your data may provide a line if your slopes are the same. So if your slopes are the same, of course it's a line. If they're not the same, it is not a line. Now, for our next problem here, let's see. Oh, good. I love this problem. So whenever you have completing the square, it's asking us to find the maximum or minimum value of this quadratic using completing the square. So you'll see I wrote out the quadratic function here, and then I said, all right, in order to complete the square, I need a perfect square trinomial. Every single solitary time, the number you need for C is always half of B squared. So I just said, well, I know that 40 is not going to be helpful, so I separated it. Now on the inside there, every time it's going to be half of this number squared. Well, half of 12 is 6. 6 squared is 36. So I knew I needed to add a 36 inside my trinomial, and I subtract a 36 on the outside. Now, this trinomial written as a binomial squared is always going to be x, and then you always keep this sign, and then you can either take half of this number or the square root of this number. So it's going to be x minus 6 quantity squared. If you multiply it out, x minus 6 times x minus 6, it gives you that trinomial back. Now on the outside, we're going to have plus 40 minus 36 for a plus 4. Now, from the very beginning of this, I knew that this parabola pointed upwards and had a vertex that was a minimum just because it's a positive quadratic. So I knew I had a minimum, and now I can see that this is a minimum at 4. This is just where the vertex has been shifted 6 units to the right and 4 units up from the origin. So I would say a minimum at 4 here, and you can see where I answered those values there, and Achieve liked it. For the next one here, it gave me, again, a quadratic, and it asked for the maximum or minimum value using completing the square. This time, in order to complete the square, I said, well, the term I need, 16, that's kind of tricky there because you think, well, that's a perfect square, but it's not the perfect square that you need. The perfect square that you need is half of 6 squared. Well, half of 6 is 3. 3 squared is 9. I needed a plus 9 there. So I separated the 16. Since I added a 9 on the inside, I subtracted a 9 on the outside. Now I would get x plus 3 quantity squared for that part here, written as a binomial. And then plus 16 minus 9 gives me a plus 7. So I'm going to have a minimum at 7. And again, you know it's a minimum because all positive quadratics have a vertex that is a minimum. We know the y value of this one is at 7. Now, that one, pretty straightforward. I love the next one. So if I want you to do the same thing with a quadratic that has a leading coefficient, it's a little more challenging. So we're supposed to determine, and in this case, they go ahead and tell you it's a minimum, but we already knew that since it was a positive quadratic. But let's use completing the square to find the minimum value. All right, so I'm going to gather the terms of x and say, well, I'm going to go ahead and factor out that leading coefficient of 5 because that is not a perfect square. I know I can't have a perfect square trinomial with a 5 as the leading coefficient. So I factor that out of the terms of x. That gives me 5 times x squared plus 6x. Now, that plus 49, I just left on the outside. Now, on the inside, just like the last problem, I said, well, how do I need to create a perfect square trinomial? Every single solitary time, whenever the coefficient now is 1, you just say, well, it's just half of b, and you square it. Half of 6 is 3. 3 squared is 9. So I need to put a plus 9 in there. Now, please be careful here. In the last problem, I put plus 9 on the inside, so I had to subtract 9 on the outside. It's not that simple this time. I put plus 9 on the inside. Yes, I subtract 9 on the outside, but since this plus 9 is multiplied by 5, the 9 that you subtract on the outside must also be multiplied by 5. Now, if you went ahead and just put minus 45 out there? Of course. I wanted to try to show where it comes from there. Now, this trinomial should be written as the binomial x plus 3 quantity squared. We still have the 5 multiplying that entire group. The outside 49 minus 45 gives me 4. So you can see, yeah, this quadratic has a minimum value at 4. Glorious problem. Now, if you're thinking that one was fun, I like the next one even more. It asked me to complete the square and find the minimum or maximum value of 3x squared minus 5x. Now, first question, easy. You already know it's a minimum. There's no question about that because it's a positive parabola there. So now, if I'm looking at how that's going to be worked out, though, I would go in and say, well, all right, I had 3x squared minus 5x. The only way that that's going to be a perfect square trinomial is if I factor out that leading coefficient of 3. I did that. Now, 3 doesn't divide into 5. That's no big deal. Just write that second term as 5/3 x. Please understand, if you distributed this 3 back through those first 2 terms, you would get this back. But now comes the step in the problem where I need to create the perfect square trinomial. Every single solitary time, the term that you need here is half of this number squared. So I'm thinking, well, half of 5/3 is 5/6. What is 5/6 squared? 25/36. Gorgeous! I add that 25 over 36 in on the inside. Now, in order to make up for that, because that was not previously there, I have to subtract the 25 over 36 on the outside. And remember that that's multiplied by 3, so the subtraction of 25 over 36 also has to be multiplied by 3. And then your inside part, this trinomial written as a binomial, is going to be 3 times the group x minus 5 over 6 quantity squared. If you multiplied x minus 5 over 6 times x minus 5 over 6, you will get this trinomial back. The outside portion, 3 and 36 reduced down to 1 over 12. So that just gives me minus 25 over 12 for that last term. And so I can say, well, yeah, this quadratic is going to have a minimum value of negative 25 over 12. And the achieved system is wanting a rounded answer on here. I don't understand why they wouldn't want the beautiful fraction there, but in my case, they wanted the negative 2.083 there. And I absolutely hated this last question. My goodness, you get to the end of the assignment and they insult you with a ridiculously easy question. I mean, what's up with that? It's just asking us to find the slope of the line y equals 6x plus 6. And so you say, well, y equals mx plus b. The coefficient of x whenever it's solved for y is always your slope. So the slope of this line is just 6. Nothing to do there. I hated that question. But keep in mind that this is just a review section. Now, if you were not familiar with that completing the square problems, please make sure you go back and practice that technique. It's a very important technique. We use it to solve out problems as far as our integrals. And if you can't do the completing the square, you are just lost in a Calc 2 class. You'd never be able to do an inverse tangent problem whenever you're integrating. All right, guys, I'll leave you with that. We'll head into the next section, 1.3, which we'll get into some domain restrictions and rational functions and some compositions. And then 1.4 starts the trig stuff. So good stuff to come.